Word Samsonite. I don't know, it just came to my mind. Sam, and I can write it however I want. Sonite. Samsonita. I want another letter. Okay. The word Samsonitia. Yep, just made it up. All right. I want how many distinct words can be made with vowels together? B. Vowels not together. Okay. It's 1. 2. Committee of 5 teachers and 15 students. And I want a 3-person subcommittee. Three-person subcommittee. Oh wait, quiet please. Ryder, put it away. With Prez, Vice Prez, that's a C. Secretary. Four-person subcommittee with 1 teacher, exactly 1 teacher. Four-person subcommittee with at most 2 students. I told you the very first thing you should do whenever you get a word is put down your phones. Then what you should do is, write it out with stacked letters. So SAMSONITEA. I'm getting ahead with my brain. Okay, so what we're also going to do is we're going to stack the letters, and then we will be like, why are we stacking these? Right, because every single question she's going to give me from now on, I'm going to have 2 factorial, 2 factorial. Oh, here too, 2 factorial, 2 factorial. I'm not even reading what the question is. I know that I'm going to have to divide by 2 factorial, 2 factorial because I'm doubling letters. Then what am I going to do? I'm going to add the letters up twice. So I have 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I do it twice because there's people who give me 9 and 11 on every single test. Some people give me like 7, and I'm like, how did that even happen? But it is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want the vowels together. Shh. How many vowels are there? There are 5. There's an A, an O, an I, and an E. What is that noise? Over. So how many options do I have for this one? 5 then.
4, 3, 2, 1.
Okay. How many letters have I left behind? 5. So then I have 5, 4, 3, 2, 1. And this would be the correct answer if I needed vowels together at the front. But we need to multiply it by how many places I could move it, which would be 6 because 1, 2, 3, 4, 5, 6, or always one more than the hooked together number. And that number will join the hooked together numbers, or after the hooked together numbers, and make its own factorial. Shh. Quiet, please. So we're going to get 5 factorial for the first ones, 6 factorial for the second ones, over 2 factorial, which if you wanted to, you could write it as 2 times 2, because 2 factorial is just 2. Now, when we put them in our calculators, we need to make sure we put them in brackets. So 5 factorial is 120, 6 factorial is 720. 720 times 120 divided by 4, 21,600. Now, it should be a big number because we have a 10-letter word here, right? But every single time you have doubling or tripling letters, it does kibosh the numbers by 2 and 3, right? Because you're going to divide it out. So if you had 2 A's, it's going to take whatever your answer normally would be and half it. If you have 3 A's, it would take whatever your answer normally would be and take the 3 out, or take out 6, because it would be 3 factorial. All right, vowels not together. We do total minus vowels together. Total is 10 factorial over 2 factorial, 2 factorial. And then I'm going to subtract 21,600 because I already found out what the vowels are together. So I do 10 factorial divided by 4 minus 2. 885,600. Now, if you leave my classroom with anything, I hope it is this. Paying attention? We group in groups of 3 from the back. We agree? What placeholder is this? The millions. And this is just a number. We agree? What? So we read this space just like the number it is. So what is that number? 1, and it's in the millions. And then this number is what number? 74. And then what spot is it in? And then 500. So it's 1,674,500. If you can read 3-digit numbers, you can read bajillion of digit numbers. Like if I had 2, 0, 6, 7, 9, 4, 5, 8, 0, 0, 1, this would be in the billions, right? So this is 20 billion, 679 million, 458,000, and this is 1. That's it. People won't answer my questions half the time because they don't know how to read the numbers. So we went through that so that you will give me answers. All right. Going back. So, we have a committee of 5 teachers and 15 students. I need a 3-person subcommittee. First, I'll have to decide, is it a permutation or a combination? Combination, because they do not have any jobs. Those 3 people picked first, second, or third doesn't make them any more special, doesn't give them anything more special. They're just on the committee. We agree? Now, did I pick any teachers or students at all in that one? Did it say anything about specific? So how many do I actually have to choose from? 20, because it doesn't specify what they have to be, and it's C3. How does that change for B? It's 20P3. Because I gave the 3 people that I chose different jobs. So the order in which I picked those 3 matters. Just like if I gave them different prizes, it would be a perm. Okay. C, 4-person subcommittee with exactly 1 teacher. I have to decide, is this a combination or a permutation? It's a combination. This is the key thing you have to know. People will say, well, if it's a teacher, they have a job. If it's teachers from teachers, students from students, it's C. If it's like forwards from forwards, defense from defense, it's a C. If you're picking from the group of people and picking that type of person, then it's not a specific job, right? You're picking defense from defense, forwards from forwards, teachers from teachers, students from students, it's a C. Every single time. Because you're not giving that teacher a specific job, it's just a teacher from a teacher. So I need exactly 1 teacher. How can I guarantee getting teachers? I would need 1 teacher and what? 3 students. I need a 4-person subcommittee. So I need 3 students because that adds to 4. Okay. How many teachers do I have to choose from? 5. So I'm doing 5, choose 1, and 20C3. 15. I don't know why I wrote 20. Sorry, 15. Okay, the next one has at most. And remember, if the cases have at most or at least, it means you're going to have more than one case, right? At most or at least means cases. Shh. So if you have at most 2 students, that means you have 2 students or 0 students. So, but we still have to have every case have 4. Every case has to have 4 in that because it's a 4-person subcommittee. Every case has to be a 4-person subcommittee. So we have 2 students and 2 teachers, because we need to supplement. Or, and I'm just using S&Ts, so 2 students or 1 student or no students. Those were our options, we agreed. But we have to supplement with teachers. So, and 4 teachers and 5, or try again, 3 teachers and 4 teachers. Now, what happens between cases when we have ors? Or and add. In between each of these, we're going to have ands. You need 2 students and 2 teachers, so we're going to multiply. So students, 15C2 and 5 teachers C2. Then I move to my next case and I get all of them back again. So now it's going to be 15 students choose 1 times 5 teachers choose 3. Plus this would be 15 students choose 9, which I could actually skip that because there's nothing. 15 choose 0. Anything choose 0 is 1. And then, 5 choose 4. So if you have 15 and you choose nothing, then you've done that one way. You just walk up and you're like, I don't want any of you. That's what you do. Me, but one way. Okay, we need to go through formulas. So, the P formula. You want to write this down. NPR equals n factorial over n minus r factorial. You do not need to memorize this. It is on the bottom left-hand side of your formula sheet. It's right down here. NPR and NCR. We're going to look at the different formulas, though. NPR and NCR. So, what type of question could I ask that would be a permutation without restrictions? So the moment I do a word and I restrict a letter somewhere, I can't use this formula. Correct? But what could I give you that would work? Yeah. Yeah. So I could do like a combination for a lock, but not restrict it to anything specific. Just say, hey, I have a 4-digit lock and I have 10 digits I can put in it. I don't say the first one has to be like a 0 or the last one has to be whatever, right? So I could go, okay, I have a 4-digit lock and I'm not putting any restrictions on it. So how many options would I have other than you can't repeat? I have to have can't repeat. Because this can't go 10, 10, 10, 10. If it does this, this formula won't work. That's still a permutation, but you have to do the blanks. If you can repeat, you can't repeat. What has to happen in order to use that formula is you have to go down by 1 number each time. That's the only way you can use this formula. So 10, 9, 8, 7, let's say. So I could say I have a 4-digit combination lock where the numbers can't repeat. So I would have 10, then 9, then 8, then 7, right? So this would be 10, P, and how many did I pick? How many blanks are there? 4. This and are the same. Same answer. So another way I could do it is I could say I have a 10-person committee and I'm picking 4 people to be on the committee. 1 gets to write down everything, 1 gets to be the president, 1 gets to be the secretary, and 1 gets to bring food. So I gave them jobs, correct? I think I said, how many did I say? 12 people? I can't remember. Let's go. We'll pretend it's 10. And I picked 4. So it's still the same thing, correct? So it'd be 10P4. Now the reason why I can do this is I have 4 spaces for those people to go into. And once this person is chosen, I only have 9 left, 8 and 7, right? So if it actually repeated, you couldn't use 10P4, even though it's still a permutation. If you said this person has to sit here and this person has to sit here, you wouldn't be able to use this either. All right. Now, where the heck does this come in handy? Well, this comes in handy when they give you something like, we'll go, I'll let you go back in your notes. Go back here so you don't have to pick out paper. This is page, I don't know what page. No, I don't even know what I just did. 5. So this is actually the Ncr formula, you just don't know it. What the formula they could have given you is they could have said NP2 equals 42, determine the value of N. Now, if they do this in a multiple choice or a numeric response, all we know is that N has to be greater than or equal to R. We know N has to be greater than or equal to R. So if this was a multiple choice, could I not just go 2P2, 3P2, 4P2, 5P2 until I get 42 is my answer? Could I not? Yeah. So do you think it'll end up being in a multiple choice? Probably not. Okay? But I could just literally plug in. I just know that N has to be greater than or equal to R, because I can't say, oh, I have 3 items and I'm picking 10. That makes no sense. Could I have 10 items P3? Yep. But 3P10 makes no sense. So this number has to be equal to or greater than that one. Now, if you're given this, if you're ever given NP2, and they ask for you to solve it algebraically, this you would fill into the formula. So I know my formula is NPR equals N factorial over N minus R factorial, and I'm just showing you how they got to where they got to. So we have NP2 equals 42. We agree? Can I not put this into this formula? This would go in for N. This would go in for R. So what would I get then? I would actually get N factorial over N minus 2 factorial equals 42. I would get this exact question. So NP2 equals 42. These are actually the exact same thing. That one's just filled into the formula. So let's take that formula and see how we can do it algebraically. Okay. We're going to have to use some brain matter today. So, any factorial symbol is literally just that number reduced by 1 each time to 1, correct? So if I gave you like 7 factorial, that would be 7 times 6 times 5 times 4 times 3 times 2 times 1, and I'd stop at 1. Do you agree? So these ones aren't numbers, these ones are variables. So if I give you n factorial, that's actually the same as n times, what's 1 less than n? N minus 1. What's 1 less than n minus 1? What's 1 less than n minus 2? And technically it would just keep going, wouldn't it? Because we don't know what n is to reach 1, so we'd actually have to keep going. Now I stopped there because you're going to see on the bottom. On the bottom I have n minus 2 factorial. So I'm going to start at n minus 2 instead of n this time. n minus 2. What's 1 less? n minus 3, what's 1 less? Oh, I don't even care. Why don't I care? What happened now? I have things that match. Right? This equals 42. I have things that match. The n minus 2 can cross off, the n minus 3 can cross off, the dots can cross off. And instead of writing dots, they'll actually write factorial symbol. Because the factorial symbol just means it keeps going, right? So instead of writing dots, they'll just put the factorial symbol and then cancel that with stuff off. So what am I left with? I'm left with n bracket n minus 1 equals 42. What do you think we do next? Distribute, yep. N squared minus n equals 42. Grade 11, what do we do when we have a squared? Get it equal to 0. N factor, yeah. N squared minus n minus 42 equals 0. What multiplies to give me negative 42 and adds to give me negative 1? N minus 7, n plus 6. And my two answers are n equals 7 and n equals negative 6.
And
Right. So 7 is the only one that works because 7 is actually greater than 2, correct? Can I ever have n be negative and choose something from a negative? No. And remember that factorial symbols stop at 1. So the negatives are out. So we circle this one with a line through it and say extraneous. And we're going to flip to the next page. So remember, extraneous is when you got a solution it doesn't work. No solution means you can't get a solution, right? Like sine x equals 2. You can't get a solution, so you put no solution. Here we got a solution that doesn't work, so it's extraneous, not no solution. All right, let's look at this one. So this one says, determine the number of total objects you have to choose from. Total objects you have to choose from. When you're arranging, arranging means it's a what? It's a permutation. The moment you arrange anything, it's a permutation. It means you're giving it order. You're arranging it. If I'm going to arrange flowers, I'm giving them a specific order. You're arranging them. Arranging 3 of those, you're arranging 3 of the total objects, and it results in 1,320 distinct arrangements. So what did I give you? We know it's a P. What's N? What's the total number of objects?
we don't know.
We don't know. It's N. What's R? How many am I choosing? 3. And what's my answer? So you have to spot that this is an answer and not N. They will have the option of you going 1320p3 and giving them an answer. They'll also have 1320pc3 as an answer. And then they'll have np3 solved and nc3 solved. They'll have every error. So you need to know your stuff. Okay, I want you guys to actually solve this one algebraically. So we need to fill this into the formula, correct? And what's the formula for NPR? N factorial over n minus r. What's my r this time, though? 3. This one we actually have to use a polynomial. So let's expand it out like we did in the previous one. N factorial expanded is going to be n times n minus 1. And then people are like, I don't know when to stop. You stop, and you only stop once they start, you know they're going to start crossing over, right? So I have to keep going. N minus 2, n minus 3, and then I can go dot, dot, dot if I want. Because there's an n minus 3 on the bottom, correct? And what does the dot, dot, dot just turn into? A factorial symbol, correct? Instead of dot, dot, dot. And then this is going to be n minus 3 factorial. Well, looky here. I went away. Now, why is this one a polynomial? Because you're going to get a cubic. You're going to get an n cubed. So we'll distribute the n in first. And you can work your way through all of this notes down to here. I don't care. We're not doing these examples. We don't have time. So we're going to have n squared minus n times n minus 2 equals 1320. Now from grade 10, you must have learned this. If you haven't, we're reminding you. You distribute until you hit an n bracket. I've discussed this all year long, trying to remind you guys what your grade 10 things. So the n distributes, I hit an n bracket, and it joins that bracket. Correct? Do I just keep going then to the next one as well? No, that n gets distributed inside that bracket, stops. It's now inside that bracket. Do you see what I'm saying? Then we FOIL. You guys have a habit of keeping going, like you just over distribute. Okay? So once I put this n in, it's in here with this. I don't put it into the next bracket, it's in this one now. And then I FOIL this one out. So I go n squared times n is n cubed. N squared times negative 2 is negative 2n squared. Negative n times n is negative 1n squared. Negative n times 2 is positive 2n. Minus the 1320 over equals 0. Because the only time you don't set it equal to 0, it's linear, right? If it's like an x1, x to the exponent 1, that's the only time where you get the x on one side, number on other, and solve, right? But if it's cubic, quadratic, quartic, quintic, you always get it equal to 0, and then you have to do synthetic division. So here I'm just going to put stuff together the same. So n cubed minus 3n squared plus 2n minus 1,320 equals 0. I brought this one up to do a little bit of review of polynomials. So type it into your calculator, into your y equals. So type it into your y equals, and you're going to look for the x-intercept. Now this has a y-intercept at negative 1,320, so if on your 1010 window you're not seeing it, that would be why. But you can go second table and see. Anyone find an x-intercept that works?
You do? 12. Yeah, it's going the wrong way.
12 and 0? Okay. So Sean got 12. So we're going to go x equals 12. Use that on the outside of our synthetic. With synthetic division, you have to make sure that you check for placeholders. Right? You have to make sure you can count down, rocket count. So we have 3, 2, 1, 0, so I know I'm good. And I can put the coefficients up here. Where does the error happen in synthetic division? People completely forget how to do it. They don't review. And 2, no rocket counting. Okay? We're going to drop the 1. 12 times 1 is 12. Add it. 9. 12 times 9 is 108, isn't it?
Yeah, that's right.
I think it is. And this is 110. 12 times 110, I'm praying, is 1320. I hope so. No, in here.
That just means we're writing there wrong.
No, that's right, 1320. And then this is a 0. And now what does this become? Can you guys try 12C3? Sorry, 12P3? Put it in your calculator. So 12P3. Worked out, didn't it? Go to your y equals and type in, bless you. Go to your y equals and type in x squared plus 9x plus 10. Type this into your y equals. This is your answer, n equals 12. But y? Let's see. Type this into your calculator. X squared plus 9x plus 110. Then press graph. How many x-intercepts are on that baby? How many times did it cross the x-axis? Did you type it in? No, you want your y equals and type in x squared plus 9x plus 110.
It doesn't cross at all.
Doesn't cross at all. It has a y-intercept of 110, and it's concave up.
No.
There's no x-intercepts here. That's why there's no solutions here, right? And if we did do the solutions, if they were negative, they'd be out as well, right? Remember that? So our answer is n equals 12. Okay? Now we're going to go ahead and we're going to do some that are C's. We're going to go ahead to the C notes. Just got to flood it. Oops, here. Right here. The combination notes, they are page 9. Okay, so yeah, permutations order matters, correct? Combinations order doesn't matter, so it gets rid of all the cases where we gave it order. So if you look at the permutation formula, NPR, it's n factorial over n minus r factorial. The Ncr formula is n factorial over n minus r factorial. But it doesn't stop there. But that looks a heck of a lot like the P one, doesn't it? The only extra they have is they also divide by r factorial. Why do you think they divide by r factorial? What do you think that does? Yeah, it gets rid of all the cases where we would give it order, right? So like if I was choosing 3 people to go on a trip, it would, out of 10, it would be 10C3. But if I was giving them jobs, it would be 10P3, and then the order in which I picked those 3 would matter. The C just takes the r factorial and it takes off all those cases where it doesn't actually change. It takes off all the issues. It takes off all the places where we wouldn't arrange it. Now this is what I need you to see. Okay? Type into your calculator 10C6. Type into your calculator 10C6. Everyone should be doing it and off their phones. I'm not doing this for myself. 10C6. What do you get? 210. Okay, now I want everyone to type in 10C4. Same, isn't it? What the heck? By the way, this only works with C's. I'm going to show you why. So we're going to type this into the Ncr formula. Okay? The Ncr formula, this is my N, this is my R. So it's going to be 10 factorial over 10 minus 6 factorial, 6 factorial. We agree? If I just plug it in? So this is going to be 10 factorial over, what's 10 minus 6? 4 factorial, 6 factorial. We agree? I'm not getting an answer, I'm just showing you. Do you see the numbers that are sitting there? See how we got them? Let's do the same with the 4. So 10C4 should be the same as we just proved. So it's going to be 10 factorial over 10 minus r factorial. So 10 minus 4 factorial, 4 factorial. What's 10 minus 4 factorial? 6 factorial, which is the other number I had. 4 factorial. Due to the commutative property, 4 factorial plus 6 factorial is the same as 6 factorial plus 4 factorial. It only works with C's, and it's the difference between the two that makes it be the same. So if I had 20 people, or say there's 24 of you, and I choose 5 of you to go to Hawaii. Okay? 24C5. But that answer's not on the diploma. What answer could they have? 24C what? Which would give me the same answer. What's the difference between these two? 24 minus 5. 24 minus 5. I really hope you can do that. 19. It'll be the same answer. It's just the difference between the two. Now they could ask you to prove to them how 24C5 is the same as 24C19. The only way you're proving that is not by typing it into your calculator and saying, oh, they match, for a 3-mark question on your diploma. Okay? You would literally have to go and fill it in to the formula like I just did and show how they work down the left and the right and explain why. Say due to the multiplication, 4 factorial times 6 and 6 factorial times 4 is the same thing. It's the common difference between the two that makes them the same. It only works for C's. Please don't give me that answer for P's. It does not work because P doesn't have that extra R factorial at the bottom, right? The other thing that they show you on your formula sheet is they say NCR can be written in brackets as NR. These mean the same thing. So on the test, instead of 24C5, they could have said 24C19, or they could have said 2419. This is the C formula. I don't know why we have one for the C and not for the P, but it's on your formula sheet. So if you see something weird, where it's like 24/10, and you're like, it's not C or P, and you're like spending more than 1 second thinking about it, you should be going to your formula sheet, and it literally tells you it's C. It's right here. This is your formula sheet, right? Just if you take these lovely, this off the edge, this is your formula sheet. Yeah.
So I think that in our calculator.
No, you don't know. Because sometimes they just give the answer in like this. Or they'll say, they could say, the answer is 24CB, where B is greater than 5. And you'll be like, but I want to go 24C5. You're like, because that's the answer. But they actually use 19, right? They could ask it this way. They could say in the form 24CB, where B is greater than 5. And then you'd be like, but I want to put 5. And then people will be like, meh, and they put 5 anyways. And I'm like, no, obviously it can't be 5. Because it says it has to be greater than 5. But you can't come up with any other reasons, so you're like, but 5 works. So that's how they could force you into 19 as well. Okay? Now, how could we have questions? So I think they're on the next page. Not this one, not this one, not this one. Good ones. Here. Extension 1, it's I think page 11. Yeah. So we're all pretty good at, if I say 20 people to go on a trip, and you're picking, 20 people to choose from, and you pick 3 to go on a trip, you know, 20 C3. We're pretty good with that. If I say we have 20 people to go on a trip, we're picking 3 to go on the trip, and we give them specific jobs, then it's 20 P3. We're pretty good at that. What we're not as good at is they can give us written response in this way, where they don't actually give us how many we're choosing from. They give us how many choose and what the answer is, but they don't give us N, right? And we have to find N using our formulas. So we'll be able to do that algebraically. Here are 2 examples. Now, an example, I'm just going to do up here. If I gave you, up here, say I gave you a circle, and it has 5 random dots on it. It kind of doesn't, yeah. But it's a circle with 5 random dots on it, also called vertices, okay? And they ask you how many triangles we make out of it. Well, we know we would have 5. And how many dots do we need to make a triangle? 3. The hardest part is to decide, am I going to put a P or a C there? Does the order in which I pick those 3 vertices change my triangle? No. If I go like this, or I go like this, or I go like this, did I get a different triangle? So is it a P or a C? C. Order doesn't matter. Okay? That's why order doesn't matter. Handshakes. Order does not matter. So if I said there were 24 of you in this class and everyone shakes each other's hands once, how many hands shake in a handshake? 2. So I would go 20C2. Because I don't care what you say, it doesn't matter, like your hands will meet eventually. Someone might come at you quick, but like they still meet at the same time. So it doesn't matter, it's still a handshake, right? So if I had 20 people in the class, C2, 2 would represent how many hands come together on a handshake. If they shake each other's hands once, it would be 20C2. If they shake each other's hands twice, what do we have to do? Nope. Still only 2 hands shaking. That doesn't change. You would just take this answer and you times it by 2. If it was 20 people shake hands with each other, guys stop, 4 times, what would we do? 20C2 would not change. I have 20 people, I need 2 hands, shake hands, done. That wouldn't change. I would just multiply by 4. This is another one that messes people up. It's sports games. So if I say that there are like 10 teams and they play each other once, how would I do that? 10 teams play each other once. So there's 10. How many teams do I need to play each other? Say it's baseball. 2. Does order matter if they're playing each other once? Nope. C. What if they play each other twice? I can times it by 2, or they could actually go 10p2. Then home and away would matter when they'd be playing each other twice, right? But I never go with the p. They could give you the option of 20p2 if they were playing each other home and away. But I don't do that because if they say they play each other 4 times, then I just put it times 4. So this always represents how many teams there are, how many play at once, how many hands there are, how many come together on a handshake, right? Or does it matter? Now here's the extension questions where they're not going to give you n. Let's look at this one. Well, they might, but we'll see. It says, in a meeting, everyone shakes hands. Boom, shakes hands. It's a C, 2 people. That's what should pop in your head, right? Shakes hands, C, 2 people shaking hands. That's what I immediately think. Baseball, C, 2 teams playing each other. Soccer, C, 2 teams playing each other. Volleyball, C, 2 teams playing each other. Do you get what I'm saying? And that, if I do C with a 2, that's playing each other once, every single time. Okay? Shaking hands once. So here we have, in a meeting, everyone shakes hands with everybody else. There are 66 handshakes in total. What does in total mean? I gave you an answer, right? I gave you an equals. That's your total. You have to watch when it says in total. How many people were in the meeting? What are they making me find? N. Now, this is a this is a written response. If you go 2C2, 3C2, 4C2, 5C2, 6C2 into your calculator, and this is out of 2 marks, you will get 0.5 for setting up that. That's all you will get. Your answer means nothing, because they'll say algebraically behind it, and that's not algebraically, right? So what does algebraically mean? Yay, I have this. Go to my formula sheet. Fill it into the formula, right? That's where your head should go immediately. And the NCR formula is NCR equals n factorial over n minus r factorial r factorial. Does not need to be memorized. It's on the bottom left of your formula sheet. You just go to your formula sheet. Go get it. This is my n. 2 is my r. I fill it into this part. Oopsies. I don't know what I just did. Yeah. So it's going to be n factorial over n minus 2 factorial equals 66. So with the p, we went right away to canceling, correct? But the r has this stupid little extra piece. That little extra piece still is going to be a number. So I'm technically dividing by 2 factorial, or dividing by 2, because 2 factorial is 2. How can I get this to go away if I'm dividing by 2? Times by 2, get it to the other side, and then I just have a p formula. Right? I have the exact same steps as the last one. So I'm going to times this by 2 factorial, and I'm going to times this by 2 factorial, which is technically just times by 2. I think it's 132. Okay, then we have n factorial over n minus 2 factorial. You try and solve this one out. It's not a polynomial. It's a nice one. Try and solve that one. So we have n minus 1, n minus 2, or we can technically go dot, 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 but we're going to put the factorial symbol, over n minus 2 factorial equals 132. These cancel. I get n squared minus n minus 132 equals 0. What multiplies to be negative 132 and adds to be negative 1? I don't remember what the numbers are. 12 and 11?
It's 12 and 11.
Yeah. N minus 12, n plus 11. N equals 12, n equals negative 11. Can n equal negative 11?
No.
Circle, line through it, extraneous. And then we would literally write a sentence. If this is a written response on the diploma, please write a sentence. Now, keeping in mind, if they say explain, you need to explain, okay? There's distinct words, and I even gave you guys on your formula sheet the describes and the explains and the compares. So, where are my 3 years one? I can show it to you tomorrow again, but there's a compare. If it ever asks you to compare, guys, if it asks you to compare, it won't say compare and contrast. It'll say compare. If it asks you to compare, you have to give 2 similarities and 2 differences. It won't say compare and contrast, it says compare. And when it says compare, it means 2 similarities, 2 differences. Okay? And it needs to be explained thoroughly, and they'll always look for words. If it says explain, you need to explain. If it says verify, you need to verify why something works or does not work, right? And every single one of them with any type of question should have a written response answer. So this one says, how many people were in the meeting? You could say, there were 12 people in the meeting. Okay? Always explain. Always write out what you found and why. All right? So here it says, there exists a circle with 6 closed dots on the circumference. How many triangles can be formed using these 6 dots? So, what do? 6, C, 3. This one was an easier one than the other ones. I just wanted to see if you tried putting one in a total. Did it say total anywhere in there? No. It just says there's 6 dots on the circumference and I need triangles. So 6C3. Show my work algebraically. It's going to equal 6 factorial over 6 minus 3 factorial 3 factorial, which is 720 over 3 factorial 3 factorial, which is 720 divided by 36, which is 20, I believe. Yeah. Okay, let's try this one. Every team in a league plays every other team 3 times. We're going to say this league is soccer. Every team in a soccer league. So how many people play each other in a soccer league? How many games play at once? How many teams? Games. Teams play at once? Yeah. So we do C2. We know that, right? And if they play every other team 3 times, what do we have to make sure we do to this? Multiply by 3. Okay, that's as far as I've got. So every team in a soccer league plays every other team 3 times. Okay. How many teams are in the league if there are a total of 198 games? Weird, they gave me the total again. 198. What are they asking me to find? N. I don't like that 3. How can I get that 3 to go away? Divide it by 3 before I even touch the formula. So I get NC2 equals 63. Because 3 into 198 is 6. Carry the 1, 8. 66, Crystal. 66. Oh, this is very similar to the one. Looks very similar to something up here in black font. It's the exact same question. All right, so we're going to get n factorial over n minus 2 factorial 2 factorial equals 66. Wait, I'm going to times by the 2 factorial. N factorial over n minus 2 factorial equals 132. N minus 1, n minus 2 factorial. Weird, I think this is 12 and 11. Oh my goodness, I'm right. I want you guys to flip to here, please. Page 12. And get the memo, hey, Ryder? I want you to try example 7 and 8.